Toilet paper gets flushed down a toilet. Let's see if it can actually dissolve in water. It quickly separates when placed and stirred in water. Further stirring will cause it to separate into even smaller pieces. It has assumed an altogether different shape, but will it actually dissolve? Let's look with the aid of time-lapse photography. A milky sediment forms on the bottom, which on closer inspection reveals what looks to be tiny bits of paper. A milky sediment will eventually settle to the bottom, no matter how many times the solution is stirred.
Yes, 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 yes.
Let's see if there is any change in weight when something dissolves in water. Let's weigh the sugar before and after it has been dissolved. The sugar in the vial of water on the scales weighs 610 grams. Let's see what happens when the sugar is fully dissolved in the water. It is fully dissolved after the space of 10 minutes. The weight was still the same, 610 grams. The sugar remains the same weight, whether it has dissolved or not.
Yes, 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 yes.
Let's see what happens when we mix acidic and alkaline solutions. Hydrochloric acid has a pH of 0.23, while sodium hydroxide has a pH of 11.76. Adding a little sodium hydroxide to the acid reduces its acidity to pH 3.4. Adding a bit more sodium hydroxide brings the pH to 6.74, which is almost neutral.
Yes, 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 yes.
Here we have a model of a fuel cell. The electricity is produced from this panel. A fuel cell requires two gases, oxygen, which is at the top, and hydrogen, which is at the bottom. The fan spins when the two gases are injected into the fuel cell. Let's see what is happening inside. Hydrogen is injected in the left side, while the oxygen is fed into the right. The hydrogen is attracted to the oxygen on the other side and passes through the sheet in the middle. The hydrogen is separated from its electrons when that happens. The electrons create a flow of electricity when they flow through the wire at the top. The hydrogen bonds with the oxygen on the other side, producing water.
Yes, 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 yes.
This fire extinguisher also takes advantage of the property of carbon dioxide. Since fire cannot burn in carbon dioxide, the fire can be extinguished. Various properties of carbon dioxide are put to practical use in our daily lives.
Yes, 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 yes.
Phosphorus is biologically very, very important. If you think of our bones, they're composed predominantly of calcium hydroxyphosphate. So there's lots of phosphate there. It's in our DNA. It's in all sorts of our tissues. And as a result, there's always phosphate in the blood, and some of it, excess, is transferred into the urine. A little bit less than about a gram per liter. This stuff is a complete tiger. You can immediately see that it starts to smoke very gently in air. And this is really a warning to us that things are going to happen if we don't sort of deal with it quickly. So we're going to drop it into this flask. The flask is actually filled with oxygen. And so it's sitting in sand just to keep the heat from attacking the glass. Now, I'm going to touch it with a hot glass rod. So there it is.
That's fantastic. And it sort of feels cold. It's not hot. That's quite beautiful.
Yes, 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 yes.
In 1896, French scientist Henri Becquerel was working with uranium crystals and found ultraviolet light made them glow.
It looks eerie.
He left uranium salts overnight on a photographic plate that had never been exposed to light. In the morning, he found a dark shadow on it and realized that the uranium salts must have been the source of energy. Becquerel had discovered radioactivity. Scientists began to investigate. One was young Polish chemist Marie Curie.
Marie began collecting uranium ore called pitchblende. Testing it with an electrometer, she found that it was 4 times more radioactive than pure uranium. She checked it 20 times. What could be going on? Then she had a brainwave. She decided there was something else in the pitchblende that was boosting its radioactivity, something more radioactive than uranium. But what? Could it be a new element? Marie Curie didn't have a well-equipped lab. It was far more basic, a bit like this. One chemist called it a cross between a horse stable and a potato cellar. She had a ton of pitchblende, some say 10 tons, delivered by horse and cart. And then with just basic equipment like this, she attempted to isolate her mystery elements.
Her experiments had a myriad of complex stages, including potentially lethal processes using highly flammable hydrogen gas.
But all her hard work was worth it. With just her primitive kit, Marie Curie discovered 2 radioactive elements. Polonium, named after her native Poland, and another that would launch an entire industry, radium.
Yes, 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 yes.
Lead. The alchemists thought it was the oldest metal. The Romans were the first to use it on a large scale. It's so stable that Roman lead pipes still survive to this day. Our word plumbing comes from the Latin word for lead, plumbum. Lead is toxic to humans as it deactivates the enzymes that make hemoglobin in blood. lead may have forced scientists to face difficult questions, but it didn't stop them forging ahead in their bid to control and manipulate the natural world. And their work with one group of elements was to spark a revolutionary idea: the prospect of creating new man-made elements.